Big Battery's new Tesla Model 3 recertified cell battery pack. So they threw a bunch of cells into a box, add a BMS, a circuit breaker, and a voltage meter, and we're going to see what's inside. And the first problem I realized is that this rivet is present, but these two are not present. I'm going to have to drill these out to open this up. We do not have a screw-on lid. But the rivets in the back are present. This actually looks pretty good. This is well made. So we have the BMS on top, so we need to remove this so we can get down into the cells. So we have a big heatsink on top and the P negative and the B negative, and this is the bottom. And I'm not sure who makes these BMSs that Big Battery uses, but they're really nice. They handle a lot of current. Even with the golf cart lithium battery, I handled a really high surge with a 240 amp motor controller. So yeah, I really like their BMSs. I've never had a problem with them. And then on this side we have the balance cable. And this metal sheet holds the BMS, and then we have a 126 amp circuit breaker on this side. And the circuit breaker connections are really nice. You have solid terminations and it looks good. And on the inside we have a 175 amp Anderson connector. And all of the batteries are glued in there with heat shrink. So I can't really see them, which is really unfortunate actually. Because honestly, I don't want to take these apart. I'd rather just test it and see if it works. Everything else looks pretty good, so I guess I'll just reassemble it and test it out. Now the battery is back together and we can start testing it. And I just found a 175 amp Anderson connector, so I can connect this battery to an inverter. Oh, we have no voltage. I guess I didn't plug this in all the way. We have 24.2 volts and 24.2 volts, so let's hook up an inverter. Now the battery is connected to a 3000 watt inverter, and we're gonna do a load test. But first we need to charge it up, so I'm charging it up with the grid. And for this battery to charge it up, we need to set the absorption to 29.4 volts. It took all day, but we're finally at 29.4 volts, so we're gonna hook up a load to this inverter and do a capacity test. We're going to pull a constant 400 watts until the battery is dead. And that'll take about 5 hours, so this is a 0.2 C rate capacity test. The test is over and we need to turn it back on again to see the results. So the final test result is 2.02 kilowatt hours. And the inverter efficiency is 80%, so we pulled 2,500 kilowatt hours, so it passed this test. So surprisingly, this is a pretty good battery. I'm pretty impressed with it. For the size, the weight, and the performance for the price, it's pretty hard to beat. Now let's talk about the downsides. Because this is a nickel manganese cobalt oxide chemistry variant, that means that the cycle life will not be nearly as long as a lithium iron phosphate battery. So that's probably the biggest downside. And usually I do not recommend most people using NMC or NMC variants for their solar power system, not because of the cycle life, but because of the safety. But for this one, because it comes with a BMS and it's in a steel box, I think that this would be plenty safe for most people. Also, Tesla has their own proprietary blend and modifications to the anode with aluminum, and so this one has less of a chance of hitting thermal runaway effect, but I don't think that would occur either because each individual cell is fused and you have a BMS, and on top of the OCPD on the BMS, you also have a circuit breaker. So I think it's a pretty good deal. I would love to hear what you guys have to say below. I think the biggest benefit in use case application would be a mobile system, such as an RV or a van, where size and weight matter a lot, and just two of these in combination in parallel could power a very large solar power system. And this thing is really small. So yeah, it does have a lot of benefits, but I want to make sure that my viewers understand the downsides by not using lithium iron phosphate. But overall, it's pretty cool. I also like the voltage range. It works perfectly for 24 volt inverters. And you can also buy an Anderson connector that they have that puts two of them in series. And then you can run 48 volt inverters. And I'm actually going to use two of these experimentally with my golf cart next week. I'm pretty sure it can handle the surge, but we're going to find out. It's a pretty big load in the golf cart, but I think that only two of these should be able to power it. So yeah, check back later if you want to see the golf cart part 2 video. But yeah, I think it's pretty good. I think they did a good job. This is one of my favorite batteries by them. Also, their A123 battery, I'm a big fan. And I didn't make much of a video on it, but I really like it. If you look at the type of cells that they're using and that they're brand new, that's like probably the best deal around. But yeah, if you guys disagree with me, please let me know below, and thank you so much for watching, and I will talk to you soon. Bye.